So to start section, this is section 2.1. What we're going to do is revisit the concept of y and x-intercepts. In 1.1, when we were talking about it, we approach it very visually. The definition's a very visual definition. There are locations where we're crossing a y or an x axis respectively. But we just left it at that. Used the technology to find them for us, all that other stuff. But here what we're going to do is approach it algebraically. Again, no matter which one, we have to remember what it means algebraically to be a y-intercept. Right? And to be a y-intercept, since I am crossing the y-axis somewhere, right, x has to be 0. So that basically is what gets the ball rolling for us when we're trying to find a y-intercept algebraically. Of course, if we're trying to find an x-intercept, we're trying to find a point along the x-axis. And along the x-axis, the thing that has to happen is y has to be 0. So we're basically back to our point plotting technique, and x-intercepts, we're going to be putting y equal to 0 into the function to find our solution point needed. Y-intercepts, we're going to let x equal to 0 to find our solution point needed. So essentially, it's still point plotting. To find the, let's start with the x-intercept here. To find the x-intercept for this first equation, again, we begin by letting y equal to 0. When I plug that in, oops, I said y, right? When I plug in that value in for y, we get 3x plus 2 times 0 equals 6. That gives us 3x equals 6. Divide both sides by 3. And I would expect this function, right, to be crossing the x-axis at 2, 0. So what other data points we have, could be just about anything, but for sure it's crossing the x-axis at 2, 0. The y-intercept, to start that journey, we let x equal to 0. So I'll go to my equation, so 3x plus 2y equals 6, and I'll simply replace the x with 0. So, and again, we're basically point plotting like we did from the very beginning, way back in 1.1. This gives us 2y equals 6, divide both sides by 2, and we get y equals to 3. All right, and so essentially the y-intercept is 0, 3. So we could begin our graphing journey, especially since this one's a line. It's crossing the y-axis at 3, 0, 3, crossing the x-axis at 2, 0, and there's basically a real good idea of what the graph of A looks like by just using my intercepts. And remember, these are all the solution points based off of the two that we found. Going to the next one, again, let me start by finding the x-intercepts first. To find the x-intercepts again, we begin by letting y equal to 0. So in this function, we just replace that y with 0, and lo and behold, we're basically solving an equation. As we saw in our review, one of the ways that we can solve that equation is by factoring. So I believe I have the right factoring via guess and check. The 0 factor property now kicks in, so somebody has to be 0, either the x minus 3 or the x plus 2 factor. Here we add 3 to both sides, and we get 3. Here we subtract, and we get negative 2. So where are my x-intercepts? We're crossing the x-axis at 3, 0, and we're crossing it at negative 2, 0. So we have 2. No surprise since we're parabolic in shape. What about the y-intercept? Well, again, the journey begins by letting x equal to 0. And so when I do that into the equation, we get y equals 0 squared minus 0 minus 6. This is all 0, so clearly y is equal to negative 6. So where are we crossing the y-axis? At 0, negative 6. So of course, we could now go to a graph, right? And we have 1, 2, 3, 4, 5, 6. We're crossing at negative 2, 0. We're crossing at 3, 0, and you can almost see the beginnings, right, of our graph. We're missing the vertex area. That'll come later in our class, but we can get a general feel for the parabolic shape that we've got taking place in part B just by looking at the intercepts. Trying to get things harder, right? Here's another equation. Let me make sure that's y minus the absolute value of x plus 2 equals negative 3. So again, don't let the equation mess up your train of thought, right? We're just basically plugging in zeros. So to find the x-intercept, like I'd like to do first, I need to let y equal to 0. So if I let y equal to 0, we get 0 minus the absolute value of x plus 2 equals negative 3. So we basically have negative absolute value of x plus 2 equals negative 3. We have an absolute value equation. And what we learned in the past, the way that we solve an absolute value equation is we isolate the absolute value. So perhaps I do that by dividing both sides by negative 1. X plus 2 now becomes 3, absolute value. And then there's two components here. Either the x plus 2 is negative 3 or the x plus 2 is 3. Subtracting 2, we get negative 5. Subtracting 2, we get 1. So we have two x-intercepts on this graph, negative 5, 0, and 1, 0. Finding the y-intercept, this time we begin by letting x equal to 0. So we get y minus the absolute value of 0 plus 2 equals negative 3. And so in here we get y, that's minus the absolute value of 2. This is y minus 2 equals negative 3. Add 2 to both sides, we get y equals negative 1. So where are we crossing the y-axis? At 0, negative 1. So whatever that graph looks like, we know where it's crossing the x-axis. It's crossing it twice. And we know that it's crossing the y-axis at 0, negative 1. So again, there's your pattern, there's your rhythm. So much math is built on just doing this simple thing, letting y equal to 0, letting x equal to 0. Last but not least, we have the equation x squared plus y squared equals 9. So how do I find my x-intercepts? Right? Hopefully you're thinking y-intercept, y, right? Y equals 0, right? So x-intercept, our y-coordinate must be 0. So plugging that in, right, we get x squared equals 9. Using our square root property, we get that x equals plus or minus 3. So this graph will be crossing the x-axis at two locations, 3, 0 and negative 3, 0. Right? What about my y-intercept? Well, again, we start that journey by letting x equal to 0. Plug that into the equation that we're interested in. That gives us y squared equals 9. Again, we can invoke the square root property. Don't forget your plus minus. And we get two potential answers. Y is plus or minus negative 3. So where are we crossing the y-axis? At 0, negative 3. And again, just visually, 1, 2, 3, 1, 2, 3. On the x, 1, 2, 3, 1, 2, 3. Right? And perhaps you guys can start seeing the circle that guy is over there. All right? So there's basically, again, an algebraic, all right, a way to find the x and y intercepts. As you guys have frequently heard me tell you, the algebra actually builds more math. So just because you can find these on your graphing calculator and just visually seeing them and punching the right buttons, that's not going to build some very good math concepts that we're going to continue to learn from and build on throughout your whole math career. So make sure you understand how to do things algebraically and that you can show me your work. All right, we'll move on to symmetry in the next video.